I'd like now to introduce our speaker for this evening, who is Julian Burnett. Julian leads IBM's business in retail, consumer products and supply chain in the UK, and he's previously held CTO and CIO and leadership positions at a number of major retailers. Very much looking forward to hearing what he's got to tell us this evening about cognitive retail innovations. Over to you, Julian.
Thank you, Simon, and thank you everyone for giving up your evenings to come and listen to me. I feel very privileged, although I suspect for most of us there's not much else to do. But I'd obviously welcome your thoughts and feedback at the end. If there's any pressing questions that you have, I think there is a chat feature that we can use to
if you've got a question, you can put a question in the question box, which you should have in front of you.
Good. Well, look, first things first, I just want to set the level here. I am not a deep specialist in cognitive technologies. And when I talk of cognitive technologies, I refer to a whole group of innovations which have been occurring for most of the history of computing. But in terms of my meaning this evening, I'm talking about artificial intelligence in its biggest definition, machine learning, computer vision, and some of the other fascinating developments that I will talk to. And I'm talking about retail at large. I'm not talking about retail in any specific category, because retail itself is a very huge industry. So huge, in fact, that we all interact with it every single day of our lives, and many of us have worked in it. The UK economy depends upon it, and I think we've all been very grateful for the amazing work that the retail industry has done through the last 9 or so months, as we've been experiencing one of the most turbulent and disrupted times for the industry. I've worked in the industry, as Simon says, for many years. I've held a number of senior leadership positions, but the thing that's defined where I've spent most of my time is about trying to helpfully employ innovative technologies to what are complex problems in retail. And retail is a complex place. It takes a lot of effort and energy to achieve what you see as you visit stores or visit websites. Behind the scenes of retail, it's quite hard to get right in every experience that a retailer provides. So that's the background. I'm just going to canter through a few thoughts, really, if I may, just to share with you my perspective on where I feel some of the group of technologies that I refer to, as does IBM, in fact, refer to as cognitive technologies, where I think we're going to see them showing up in our lives as we engage with the retail industry. And I'm really simplifying here to try to bring it to life with a few examples of where we are as IBM and where we see others employing these technologies and what the purpose is behind it. So I think cognitive technology is going to play a role all over the retail industry. But one of the areas that we've found over the last few years actually making a real difference in the use of these technologies, actually helping to understand what people are going to want, what they're going to like, and the process of developing the product offer to consumers has been greatly enhanced, particularly in the fashion industry, by work that we and others have been doing to fuse together design with technology and to try to create a level of prediction about what might work. There's a few examples here about harvesting large amounts of data from social networks to inform the colour way that fashion garments will be used to promote and respond to customer needs. Their partnership there with a leading designer and IBM was all about that, how to make sense of a huge amount of sentiment, and from that sentiment to arrive at a conclusion for a new spring summer collection and a new autumn winter collection, and to try to pitch the colour of those against the huge sentiment that had been gathered. So we think that those cognitive technologies will start to play a very significant part. Actually, this went beyond colour, and this was a collection of garments that were almost entirely determined by using external data sets, largely photographic data sets, to determine and judge what was hitting the catwalks, what was being shared on Instagram, what was being and Watson came up with both the look and the style and the fabrics and the colors, and made recommendations and suggestions about what the range of garments might be that Jason Grech, the designer, then selected from. So very much a fusion of cognitive capability on one hand and Jason's own creative flair coming together in this range of garments. We all know Siri. We're getting to know Alexa, and if we're lucky, our Android phones have Hey Google, and all of those services are using natural language processing capabilities. Another arm of the cognitive technologies that we are interacting with, whether we like it or not, whether we know it or not, in many cases, we are. So at the top, lots of voice-based capability, and I'll talk a little bit about some of the automation of conversational technologies and their role in contact centers and other places in the retail industry. At the bottom here, a whole range of visual capabilities that are being used now for the ability to find stuff visually, searching for particular comparable products to the ones that you're seeing online or on people. And the example on the right is a bit of demonstrator of what you can do. You can find all of the attributes of a particular garment just by looking at it, classifying it, categorizing it, and then using that as search criteria to go find that stuff on selected websites. And so there's a whole range of capabilities in that visual computer vision space that are starting to become real. One of the most amazingly complex conundrums for retailers is encapsulated in that term. How am I going to predict where to put stuff, what to charge for it, how to promote it, and that complexity when you are a supermarket retailer, for example, ranging 50,000 different items into 1,500 different stores, and then it rains, or there's a road traffic event that causes a challenge to fulfilling the replenishment of stock to stores, or there are other factors at play. What we have here is a set of technologies that combine They used to be called the IBM Metropulse. I think the term is no longer that, but underpinning this is a set of collections of real-time event-based data that comes together at a point in space. So the primary feature here is the prediction of what is happening in a location, and we've used these technologies in various capacities, sensing of weather information, traffic information, social media information, website traffic, all coming together to help store managers make the most of the operational day that they have in front of them. A lot of retail is set up ahead with plans for the day, but of course interruptions, disruptions take place all the time, and in the moment the store team has to handle that scenario. With this assistant, they can start to see the dynamics at play in their local space and start to react and respond much more effectively. They can also start, and this is a really important feature right now if we think about the world we live in today, they can also start to optimize the utilization of the physical assets that they have. So on one hand, what product I have and the stock on hand of that product, but the space that I'm in. How do I put together the combination of those things in the most cost-effective and value-effective way to yield from the assets that I'm now managing, stock, space, and the third dimension, which is always a big cost in retail, labor. So those three things are the most challenging for any retailer in combination: stock, space, and labor. They represent the three biggest costs, the three biggest risks, but also the three biggest assets. And so optimizing those through the combinations of these real-time event-driven data sets analyzed to allow greater levels of predictability and forecast of demand and supply, because on the other side of this is a highly dynamic supply chain. So retail is this conundrum of trying to constantly balance demand and supply and optimizing the space between the cost of stock, the cost of labor, and the cost of the space that retailers occupy. Now, clearly, not all retailers have stores, but even those without stores have costly distribution and logistics operations, which account for a very significant proportion of their costs as well. So the application of cognitive technologies to this space is probably the most likely to yield for retailers competitive and cost advantage. And we're certainly seeing a great propensity in the conversations we're having with all of our retail clients to focus on this. How do you optimize in those three big costs and the assets that they represent when you've got highly volatile demand on one side and highly volatile supply on the other? And we've worked with some retailers very recently using a combination of computer vision in the back of their stores to track the movement of product into and off the lorries and into the back of the store and out to the shelf and then all the way through, just to try to help them when they've had fewer people available in stores because of social distancing rules. So there've been some real-time examples. But if I move on, one of the greatest challenges of retail from the product's perspective is getting your products right. So great products sell well, poor products don't. the difference is often marginal between the tastes of the consumers that you're serving. So if you can start to close the gap between your customers' needs and the products you sell, and be able to offer a range which is a closer fit, then you're likely to increase sales. It's as simple as that to say, but the complexity of retail is that you're anticipating your customers' needs, and you're sourcing products along a very lengthy supply chain, which can take months of development effort, further months of commissioning effort, and by the time products actually start to flow into stores, the moment may have passed. And so personalizing products in the moment when demand is being expressed by customers makes a lot of sense. And you can see three examples here. One, a gin, which can be customized online. You can add and remove various botanicals and make up your own gin. The Nike example here, which is just a customizable trainer. You can choose the colorways, you can choose the combinations across actually quite a wide range. And then the final example of the jumpers, these are in-store manufactured and personally designed jumpers that are made by Adidas. And they all use a different combination of technologies, but in common, personalization is served throughout by the use of, in some cases, artificial intelligence, in some cases, more about learning and predicting and recommending, learning, predicting, recommending, and refining the selection of products against the likelihood and propensity of customers to align their needs to them. And we all experience this on many occasions when we visit websites and we see the recommendations being made when we visit a particular product or a combination of products. Those recommendations engines are using machine learning to constantly refine the set of recommendations that are being made to you. This takes it to another level entirely, right? This I simply don't get. I simply don't get it. This is an organization called Carling. They're a fashion brand. They are using social sentiment to create garments which are entirely unique, one-offs that can be owned by only one person, but they don't physically exist. These are digital garments solely for the purpose of sharing them through social networks. But what they're also doing is creating a feedback loop based on sentiment that those same social networks express towards those products, designed by these people, showed off by these people, to actually close the loop back into their product development life cycle. As I said, I don't get it because I'm not necessarily quite as active on the social networks as the folk you see here, but these are entirely virtual products. They cost real money. Individually, these garments have a price tag, and genuinely, people exchange hard currency for those entirely virtual products. Back to the real world then. We experience this all the time. We go into stores and we're increasingly engaged by the experience. The retail world is moved this year to a place, of course, where we hope stores will return for our enjoyment. 11,000 have already closed this year alone. But there are movements afoot in retail to create much more engaging, immersive experiences for customers. This is an example of a store, tiny little store, that's using a whole range of different technologies, techniques, called ProDirect. And I'd encourage anybody, when it's possible to do so, to take a trip down to Carnaby Street and have a look at ProDirect. If you're interested in where the future might lie, this store's been around for 6 or 7 years already, but it points to a future because it is an entirely digital experience inside a physical space, and that space is entirely reconfigurable. All of the digital assets that you see here on the left in terms of the imagery and the key, what you can see on those screens there, is entirely configurable. It's in fact a set of magnetic walls that take flexible magnetic tiles, which can be printed with all of the digital assets. To recreate an entire store takes them 24 hours of turnaround time. The reason I have it here is because actually the much more mundane version you can see on the right isn't quite so fascinating, but this is an example at made.com where actually what they do is use review content from their customers as their marketing material. So if you're in their store or on their website, you're consuming assets from their previous customers, user-generated content. It's a classic retail trick. Get people who bought your product to sell more of it for you unwittingly by sharing their photographs. But the purpose of this is actually to call out that there are these combinations of techniques and technologies that are bringing a really different experience to the retail store, and using lots of predictive capability to judge people's reactions and responses. So not only is the ProDirect store that you see here showing, it's also listening. So they've attempted to try to recreate the experience we have on a website, and they've got a series of sensory technologies that are monitoring in-store activities as well, and looking at the propensity, as you would on analyzing a web visit, the propensity of people to pause a little longer, to look at things, to engage, and they're using the insights to try and refine the experiences that you're having. This is a really big issue for us right now as an industry. We're all staying at home. We don't want to go to shops. We want stuff to come to us. And so the convenience factor of home delivery is high on every retailer's agenda. The challenges it creates, though, are another level of complexity to wanting to put things in places in anticipation of demand. Stores are fixed locations and pretty predictable. When you open your door, once upon a time, people would come through. You have fixed constraints. In a world where convenience is now driving people's choices across a whole multitude of different delivery propositions, collection propositions, actually having enough insight into where people are, where demand will come from, where you need your stock at any point in time, just grew an order of complexity. So all of the challenges that I talked to earlier are now being magnified. And so technologies are being used to try to make greater predictions about where to have things in space. Where do I need my stock? How do I anticipate demand relative to a particular point in space and time? And how do I redirect my assets? And in many, many cases, the assets I'm now talking about are those of third parties. So distribution, logistics, delivery firms. How do I make sure I bought the right quantity of Deliveroo slots? Because you don't just pick up the phone and say, hi Deliveroo, could you just take Mrs. Jones her toilet rolls? There has to be a level of commercial reality to bringing some of these technologies to bear to try to improve what is a highly inefficient industry, made more so by the fact that we're all now much happier for stuff to come to us than for us to go to the stuff. But then when we do go, we encounter people. And retail is one of those industries that accounts for a very, very significant proportion of the UK workforce, directly and indirectly. I think by last count, there were something like 7 million people in the UK economy that would play a part in the retail ecosystem. That's a sizable proportion of the working population. It's a very people-centric business. And so when I talked earlier about optimizing stock, optimizing space, how about optimizing labor? The people involved. How do we keep retail people engaged? There are many hundreds and hundreds of thousands employed in the industry. And so there are a reasonable amount of investment being made now in technologies that try to keep people engaged, try to keep people happy, and try to keep people performing. And I call out three here in particular. HireVue, having a bit of problem with HireVue. They're using computer vision and video analytics in the recruitment process. I call it out as a problem because actually it started to demonstrate some unhelpful bias and behaviours, particularly around people with facial disfigurements or neurodiverse conditions that don't necessarily fit the data set that the organisation hiring using that technology. In the middle, Corso, fascinating small company, I know them very well. They're using nudge politics, I would call it. What they do is they analyse the performance of huge volumes of data across big retail estates, and they start to look for performance differentials between particular aspects of a retailer's in-store performance or across stores, start to make suggestions about how to improve performance through action. And those recommendations, almost like recommendations engines on a website, they're offering suggestions to colleagues in store about what to do next. So assisting the performance improvement by gradually moving people up the bell curve in their ability to perform a task or achieve a goal. And that's a couple of examples there, but where I start to feel this is moving is actually towards the level of insight you can gather that drives not economic outcomes, but social and environmental outcomes. So a few examples here. On the top left, we've a presence analysis. So this is looking at in-store, looking at optimization of position of product, looking at the busyness in the store and trying to figure out a way of optimizing not only the product but also the environmental conditions. More people in a space, it warms up, so you need to cool it down. And over on the right, some other capability around buildings analysis and looking at the environmental performance of buildings relative to populations of people. And then the example on the bottom there is a vertical farm, but that vertical farm is inside a shipping container. It's been created as a controlled unit. It's dropped into locations close to demand, and is growing salad product. But the clever thing about it is that it's entirely controlled. There's only one person required to run it. All of the hydroponic fertilization and feed is controlled, and it's variable relative to the growth rates, the environmental conditions, and so it's optimizing the yield at the lowest possible costs in terms of environmental impact and in terms of fertilization. The aim here is a set of technologies that can be applied to really try to reduce the amount of waste and preserve the resources involved in the upstream aspects of the retail industry. And of course, cognitive technologies are all about robots, aren't they? We've lived loving the idea of robotics, and there's an awful lot of capability required to send a little robot around picking in a complex retail fulfillment center, which you can see on the left. And Ocado, a client of ours, are making huge strides with their robotic capabilities, and every single one of their capabilities depends upon cognitive technology to determine its location in space and time, its proximity to each other, and the product selections that are being made, constantly dynamically recalculated where to go find that thing. But of course, automation isn't just physical robotics, it's also the automation of processes. And so bottom right, here's a chatbot that H&M have developed with us, which is actually much more than you might imagine. It is not just a silly little text conversation, it's an entire shopping journey through conversational, natural language process-based automation. You can talk to or text to, but you're going to get a pretty engaging conversation which guides you through the shopping experience to the point of transaction and beyond. So a wide range of uses I've described so far, and some of the things that start to excite me about these technologies, simply the volume of data that can now be captured, processed, and applied at such huge scale. The levels of complexity in retail don't stop at the back of the shop. They go all the way back to the farm. And we've been working with a number of very big retailers in the US and in Europe, applying, and a number of food service organizations applying a whole range of different capabilities to drive up the level of transparency available at any point in time in the supply chain, from the fishery or the farm all the way through the processing, the productizing, the packaging, the distribution, and ultimately the consumption of product. A lot of it's underpinned by blockchain, and a lot of it is underpinned by the use of Internet of Things sensory technologies connected to the blockchain to create effectively a digital end-to-end capability that from which we can drive huge insights at so many levels of granularity compared to previously. So the examples here, the mango, product safety and product recalls is a big problem in retail. The minute something goes wrong in a shop, it's too late. You have to withdraw all examples of that product off the shelf. you have to put recall notices out, you have to try to make contact with customers that may have bought something that could be harmful to them. Massive amounts of product is wasted as a result, and lives are genuinely put at risk. The example here, we used a platform which IBM has developed called Food Trust. In a typical scenario, withdrawing a product for sale in a shop and then stripping it out of the supply chain all the way back to the point of origin to ensure that there is no risk to the safety of that product can typically take a week, and it's a hugely costly affair, and it's very manual, particularly if the supply chain has been a particularly long one. And think of a ready meal. Think of the number of ingredients in a ready meal. If one of those ingredients has something wrong with it, think about the complexity all the way back to try and trace where that problem commenced, come all the way back and take that product out. The alternative is that you connect points along the supply chain and find the optimal number of points so that you can trace back using the blockchain. The mango example is one from Walmart, where we, instead of 6 or 7 days, took 2 seconds to identify the tree upon which the mango grew. It was just a test exercise to show what is possible. Bottom right, tiny little picture there of a very big ship upon which there are hundreds of shipping containers, within which are thousands and thousands of products coming across the oceans, and every single container on that ship is being tracked on a blockchain. Every consignment inside the container is being tracked on the blockchain. We combine that with real-time weather data to show where things are in time and the likely passage of those products up the supply chain towards the retailer. If that's fresh produce, just to give you a sense of what I might talk about, it's unlikely to come on a shipping container. It's going to come in a plane. But some products do spoil with time. Some products actually you want in your stores, and you want to start promoting them with some certainty about their arrival times. You might imagine that retail supply chains contain this level of information. Unfortunately, they don't. The number of breakpoints along retail supply chains are amazing. So getting any level of insight is an improvement, and the improvement translates into more certainty of supply. More certainty of supply can translate into more effective spend on marketing and actually start to drive greater certainty of labor requirements in every point towards the store. So these things are coming together at an amazingly rapid rate. We've just completed a piece of work with GS1, the Global Product Data and Barcode Standards Organization, to explore how we can start to drive this kind of detailed insight into the food supply chains for the UK, including the origins of seafood, of meat products, of dairy products, and their combinations all the way through to the point of consumption. Not least because we care about food safety, but we also care about efficiency. And efficiency in retail at the scale of its operation translates into huge marginal differences in the financial performance available, but also translates into huge differences for the environment. One of the other areas we're exploring, and there's a range of examples here, show the use of computer vision and accelerated on-chip analysis that allows low-cost devices like mobile phones to be married with artificial intelligence on these chips And the examples, if I run from left to right here, bottom left, we're doing some work with a very large global fertilization organization called Yara. What you're seeing there is a visual analysis of a field that's been photographed from a satellite, and then with a backup photograph, digitally photographed by drone, and it's using visual analysis of the crops to determine the fertilization requirements of those crops, so that when those fields are fertilized, they're not over-fertilized. In fact, they're optimally fertilized, reducing waste, reducing cost, improving yield at the lowest possible intervention of fertilizer. Now, you'd argue, why is a fertilizing company trying to reduce the amount of fertilizer it sells? Well, it is, because it's actually a values-based business and it cares. And it has an ethical mandate that it's trying to use technology to automate. The example of the mobile phone, this is a authenticity checker. It's called the IBM Verifier. Uses visual analysis. That's a basic mobile phone with an adaptation. And it allows the visual signature of a thing, in this case, whiskey, to be recorded. And for that record to then be used as a provenance test on other versions of that product. Counterfeit whiskey was the problem we were solving now. All the way through to the right-hand side now, this is a fascinating example where produce, like oranges, has a pretty predictable rate of deterioration. And that rate of deterioration is determined by a number of factors. But one of the things that's really interesting, if you leave an orange, it will rot, because the minute you take an orange off a tree, it's dead. And its deterioration occurs through the levels of humidity, temperature, and the physical conditions that it's handled through, but it's definitely deteriorating at a pretty determinate rate. What that technology example shows is we're using visual analysis to test the level of deterioration, fine detail differences between what it looks like, basically. If that orange could be tracked through its supply chain in terms of all the combinations of the factors that lead to deterioration, and it could be judged to be less deteriorated by the time it gets to sale on the shop floor, it has a longer life. And that longer life translates into full price sales. It could be sold for longer, for more. Quite simple. Rather than the manual sell-by dates that are attached in the distribution center before the oranges leave for the stores, those sell-by dates could be variable. That variability could translate into huge additional shelf life because of the knowledge attached to that individual orange or that consignment of orange. The knowledge of its, the humidity conditions, the temperature conditions, and the physical handling conditions that it's experienced along its life, or in fact, it's along its death. So you can imagine some of these things at scale being applied to cases like that, making huge economic, but also environmental impacts. The challenge it provides us as an industry is, with this huge amount of possibility comes huge amounts of data, and with huge amounts of data comes huge demand for very, very, very fast analytical computing capability, which is why IBM has invested very, very heavily in the future of quantum computing, and why it's also taking an interest in applying technologies at the edge, close to where that analytical capability will provide benefits to clients. So the combinations of Internet of Things technologies, vast compute capability at the center but fast analytical capability at the edges, combined through blockchain for security and transparency, adds up to something that I feel provides a combination of capabilities that the retail industry by 2025 will have wholeheartedly embraced. Perhaps not in all of the examples that I've shared, but certainly in some. And the conditions that the industry is working in today is actually accelerating the adoption of some of these cognitive connected technologies. And that was it. I hope that was of some interest and showed some of what might be happening around us today already, and what might happen over the next few years.
Many thanks, Julian. Fascinating talk on a very wide-ranging topic. Julian's kindly agreed to answer questions if anybody's got them. So if you have a question, can you please use the questions window in the GoToWebinar, if you type in a question, we will pass them on to Julian and consolidate them as might be necessary. I had just to kick off, I had a question for Julian, which is basically, are we seeing a radical change in the nature of the physical retail space? Is it moving away from being somewhere which actually does the sales and fulfillment to being somewhere that's just a showcase for a behind the scenes operation to provide the actual items?
Simon, I think the immediate answer, and I say it in terms of the conditions that we're working in right now, it is certainly accelerating the use of stores as fulfillment points for home delivered or collected product, in addition to the more traditional store visit. There have been a number of attempts in the last few years of creating a hybrid between a showroom and a store and a fulfillment center, and there are a few trials happening right now. I think we have to point to a future where the experience will be different, and a blend between a fast in and out shopping trip, probably employing a self-scanned rather than a checked out. That is happening already. 37% of Sainsbury's sales in the third quarter were made by people in a shop using a device to scan their own shopping and paying and leaving. 37%. That points to an experience that people want. They don't want necessarily to spend a lot of time shopping. Today, I think that's being driven by the safety issues, but also by social distancing and by other factors. I think in the future, what we will see is the physical retail space becoming multi-purpose: showroom, shopping, and fulfillment. And I'm working on projects with clients to that effect right now. By the way, there is too much space relative to the demands of the industry and us as customers, so it has to be put to better use. And I think that blend of experience, self-shop, and fulfillment we'll see much more.
Okay, thank you, Julian. We've got a question from Mike Beardmore, who's asking, how does in-store monitoring keep consent with customers? I'm assuming that's when you're referring to those, possibly those heat maps.
Yeah,
when
it's interesting because we
around the store.
stepped away from investment in facial recognition technologies. Very formally, we're not investing in facial recognition technologies. We are, however, investing in a range of technologies that do not require consent because they don't actually involve capturing of people's personal data or images. The privacy issue is one for us that's quite paramount here. The sensors being used are many and various, and are using effectively just trying to get a fix on movement rather than person. Some are using the fact that we have one of these in our pockets that's a proxy for a warm body moving around in a space. A very simple Bluetooth, low energy sensors can be used to just determine that there are a whole bunch of these things wandering around. It's got nothing to do with the phone. It's got nothing to do with the person whose pocket's in. It's just a proxy. So, but as I say, facial recognition and the issues of privacy are things that IBM as a company we've made a conscious decision to get out of, other than where they are specifically applications for national security and the like in other scenarios, but not in retail.
Okay, thank you. I've got a question from Sheila Lloyd-Lyons, who wants to know, is the food retail market making enough money to continue good funding of the technology?
Today, there's a huge challenge. Margins in grocery retailing are always tight. You know, it takes a lot of cost. However, some of these technologies have the potential to drive very, very significant efficiencies from which profitability can be improved. My comment about the three big costs, stock, space, and labor, small marginal improvements can lead to very significant financial gains, and optimizing in those aspects of retail that I talked about is definitely worth investing in. Now, some would say I would say that, wouldn't I? Because I'm trying to sell this stuff. But genuinely, you know, a small percentage improvement in any one aspect of those things can be a huge material advantage. But this year, grocery retail has a real conundrum. It's seen sales rise, but it's seen cost rise faster. And if the question is motivated by have they got much left to spend on tech, well, probably not quite as much as I would hope, and not as much as they had last year. But I would imagine that it'll start to improve into 2021. Certainly, I've had many a conversation with my retail clients who are still spending money on things now that are making the differences that I've talked about, tightening up the demand supply conundrum. Working capital is a precious commodity, and if you can spend less on your inventory, for example, and still achieve the same sales because you're reducing wastage, then for sure there's a business case there.
Okay, thank you. So next question comes from Jeff Stone, and he says the area that particularly interests him is logistics. How do you see the transport industry changing to adapt to the increased demand, particularly highlighted by the current situation?
Well, thank you for that question. in a former life, I ran the distribution and logistics function for a retailer alongside the tech, and I have to say I get quite excited by by the combination because. But to answer the question directly, the distribution and logistics industry has played a huge part this year, in particular because of the rapid acceleration in demand for online fulfillment of product to people's homes. It's put them under amazing pressure, and it's one of those industries that doesn't normally invest heavily in technology outside of the distribution centres. What it's found itself having to do this year, though, is manage its capacity much more effectively, because the demands upon it have been so unique. And I think it's pointing to a future in the transport industry where actually the investment in cognitive technologies is likely to rise quite steeply as a proportion of its investment in technology. Automation inside the warehouse as well, where the tools and techniques of yesteryear are no longer effective at the scale of production that a typical fulfillment center requires. So I'm seeing a big increase in spend on AI and robotics combined into distribution warehouse automation technologies. So I think I'm heading into that market much more than ever before in our IBM business. In fact, just yesterday, talking to colleagues about it, that we will certainly find ourselves working more in that part of the industry. They are an intrinsically integrated part of the ecosystem in retail, and there's one particular aspect of this that I think is going to start to appear, which is how to collaborate in the optimization of our transport networks. There's an awful lot of fresh air involved, and fresh air is very expensive if it happens to be in the back of a delivery van in a warehouse or container. So the eradication of fresh air through the application of technology, that's a mission I've just set myself.
Right. Well, I think quite a lot of that fresh air is actually in bubble wrap as well. in that the boxes are often too big for the item that's containing it.
You know, I think consumers will start to demand of that part of our industry a response to sustainability and the environment that it has, and I think that will cause distribution logistics organizations to sit up and take notice and start to think about how they again use technology to optimize the environmental impact of their operations.
I think might be there's a relation to another question from Brian Day, who's saying there's a large return rate for online orders. How do you see technology assisting with reducing that?
Well, I had to handle that problem when I was at House of Fraser, and it is alarmingly high in some categories. Women's occasion wear, in particular, was coming back at a rate of 70 or more %. Items had to be sold 2.7 times to stick and not come back. The cost involved in that are huge. One of the things that so I think there are two answers to this. There's a set of technologies that try to reduce the likelihood of it coming back by getting it more right in the first place. The reasons for returns tend to be it's the wrong size, the color didn't look as it did on screen, or a combination of the two, or the quality of the product when I got it wasn't what I'd anticipated for the price. And so there are a set of technologies used at the front end to try to improve the likelihood that you're buying something that you will ultimately want to keep. That can be, there's a product that we use called TrueFit in the fashion industry that uses big data to try to really gather a level of insight into what the real size of things is versus the size on the label. And there are others that are designed to try and do color correction as well, making sure that actually if it looks like this on screen, it's going to rock up and look the same when you get it. So there's that side of it. The other side of it is actually about what happens when it does come back. One of the things that happens is you lose sight of your inventory. So what's happening, you've sold it and you've got money, you've now given money and you've got inventory, but you don't know where it is and you don't know how to handle its return into prime condition to resell. And so there's a lot of effort, certainly, that we're helping clients to try to get some of that visibility. You go blind as a retailer in many scenarios. You've got one hand over, you just don't know where anything is, and loss of sight in terms of the inventory can be improved by a number of techniques and technologies. And the third is actually the reprocessing of it, because a product that's come back twice already starts to deteriorate. And so in the physical world, actually quite a lot of the distribution and logistics operators have got dedicated returns centers that are operating inside distribution centers and are doing some quite clever stuff to grade and repackage product in an automated way as well. But they're really expensive. And I'll share this with you. I bought something for House of Fraser, this one machine that was a combination of a steamer and a re-ticketing and a rebagging and repackaging. And it's a £600,000 device. It just stood there. You put clothes that had come back in one end and out came prime clothes at the other. It was worth the investment for certain. It reduced wastage and it created an opportunity to then reinvest in some of the other parts of the returns process. But yes, it is a problem.
Just looking to see if there are any other questions, but I don't have any at the moment. I just had one other one, which is, there appears to be quite a high entry level into a lot of this technology. Is technology also going to be helpful to the small local retailers that we seem to be losing at a rapid rate, or is it inevitable that we'll lose them?
I don't think, I think actually, contrary to popular belief, local retailers are doing better than many because we're all staying at home and happy to go down to the local shop. I think the biggest challenge for a local retailer is actually scaling if it wants to, and then technologies are of course available. If you look at the cost of a typical e-commerce tool to take your business online, once upon a time, not that long ago, a big retailer that you'll all know, and another one that I worked with subsequently, would have spent tens and tens of millions of pounds on technology investment to build their online shopping experience. You can now get broadly comparable technologies from a whole range of software as a service platform providers like BigCommerce, like Shopify, and others that are entirely variable rate in terms of cost, because software as a service and the underlying cloud economics that drive software as a service have started to really reduce the cost of capability for small retail. The other thing that's happening is that big platforms are being created upon which local small retailers can sit. And not only do they have the technology, but they have all of the fulfillment capability as well. And so I've seen local retailers who have one store suddenly explode online and can't cope with the volume of demand. But the cost of entry actually, now is pretty low in comparison to 10 years ago. I mean, at like an order of magnitude, if not more, lower.
Okay. Yeah,
and why have you decided to get out of that market, by the way?
I have another question from Jeff Stone, who says, can Julian comment on the likely change in where products may come from in the light of the global pandemic and political changes related to globalization and Trump and the B word?
Well, I can comment professionally or personally on that. I don't know which you'd prefer. But I think sourcing is, well, it's been, interestingly, sourcing of product has been significantly disrupted by this pandemic. Buyers would typically be out and about looking for stuff all over the world.
Yep.
And that stuff, they'd have bought samples back, they'd have, none of that's been possible. Yep. And actually, I think we will start to see, through simple necessity, a need to source more closely to the point of consumption. And if you look at it through the eyes of an environmentalist, of course, there is some massive advantage of having something grown closer to where it's eaten or manufactured closer to where it's worn. But the industry at large has a real challenge in the amount of visibility and transparency available in supply chains. It is the boohoo situation that we've all witnessed in the news is a testament to that. It's actually quite hard to have quality and a creditable quality in sourcing. And so I think there's another dimension to the answer, which is if you've got an environmental agenda and you've got an ethical agenda and you're being driven by very significant rules and regulations about it, you're likely to be able to comply and achieve those outcomes by keeping your sources more local to you. So I do think we will see that. And certainty of supply is something that retailers depend entirely upon. And if you can't get that certainty because there's a global disruption occurring, then of course, again, another good reason to try and find alternatives closer to home. And I didn't mention the B word once then.
Right, thank you. Or the T word. Right. Well, thank you very much, Julian. I think we've come to the end of the questions. I don't see any more. So it remains for me to thank you very much for the talk this evening. It's a bit tricky. I'm sure if we were in a physical meeting, there would now be a hearty round of applause, which is not very easy to do through the technology. But I will applaud on behalf of everyone and say thank you very much, and we very much enjoyed this presentation to the branch meeting. And I'll conclude the meeting.
And thank you for the questions. I appreciate them.
Thank you. Thanks very much.